Assalamu alaikum and hello again. Now we are talking about topic 6.5 manufacturing applications. You will find it in your textbook page 105.
You might have an idea of a computer as being something with a keyboard, a mouse and a screen. Alternatively, you might be more used to a computer that is a single integrated unit, such as a tablet or a smartphone. These are two forms of computer, but they are not the only two. There are millions of computers in use today that bear no resemblance to what you might think of as a computer. That is because they are embedded devices. They handle inputs, outputs, storage and processing. They form part of larger devices that perform other tasks. This pod looks at control systems and manufacturing systems.
Computer systems that form part of the manufacturing process are known as computer-aided manufacturing or CAM technology. Two examples of CAM devices are laser cutters and 3D printers. While these used to be expensive tools of industry, there are now hobbyist versions that can be found in schools and even homes. A laser cutter uses a laser beam to either engrave or cut through materials such as wood and plastic. A computer chip is used to precisely control the position and intensity of the laser beam. A 3D printer uses an extruder to deposit molten filament onto a flat surface, building a solid object up layer by layer.
At the more expensive end of the scale, robots are used to assemble larger products, such as cars and household appliances. Different robots are assembled with different pieces of hardware, including drills, saws, hydraulic arms, and welding equipment. Again, each of these components is precisely controlled using a computer chip.
Computers can be used in far more applications than just manufacturing. The capability of a computer is dictated by the hardware connected to it. A computer might be used in a greenhouse to monitor the temperature and open and close windows as necessary. In order to do this, a temperature sensor would be needed, as well as a motor that can open and close windows without human involvement. At regular intervals, possibly multiple times per second, the computer takes a reading of the temperature. If it is above or below the preset value, the windows are open or closed accordingly.
What was just described was a feedback control system. The behavior of the computer is determined by external considerations, in this case, the temperature in a greenhouse. There are many other feedback control systems, including some in your own home. If you set a temperature on a washing machine, a temperature sensor might be used to check whether the preset temperature has been reached. If it has, the wash cycle begins. If it hasn't, the water will continue to be heated.
There are also non-feedback control systems. In these systems, the computer manipulates other hardware without using sensors to monitor the outside world. Let's look at the washing machine example again. If a different model heats the water for a preset amount of time without checking the temperature, that's a non-feedback control system. With fewer components to make such a system, it would be cheaper, with less scope for hardware faults. But it would also be less reliable than a feedback control system, since it would be unable to check that the required task has been performed.
Manufacturing using ICT, which is automation, in number of areas. Why? To improve productivity, reduce costs, improve consistency, and make factories safer, and make these factories more environmental friendly. Now, one of the examples of this automation is using robots. Robotics or robots are used for paint spraying of car bodies, welding bodywork on cars, manufacturing of microchips, manufacturing electrical goods, and automatic warehouses. Now, control of robots is either through embedded built-in microprocessors or linked to a computer system. Programming of robot to do series of tasks is generally done in two ways. We have 1 and 2. Robot is programmed with sequence of instructions which allow it to carry out the series of tasks like spraying car body with paint. As we saw, it is just static work and has the same instructions every time. And the other way is that the human operator manually carries out the series of tasks. This can be done in two ways also. One of them, the robot arm, is guided by worker when spraying the object. Each movement of the arm is stored as instruction in the computer. The second way of this method is the worker straps sensors to his own arm and sprays the object. Each movement is stored as a set of instructions in the computer. So later, the sensors send back information such as position relative to the object, arm rotation, and so on. So by this, we have the methods and the second method, how it is done in two ways. Whichever method is, once the instructions have been saved, each series of tasks then can be carried out by robot arm automatically. Now each instruction will be carried out identically every time, giving consistent product. Robots are often equipped with sensors so they can gather important information about their surroundings and also preventing them from doing stupid things. Stopping a robot spraying a car if no car is present, or stop the spraying operation if the supply of paint has run out. So, using sensors for robots, it is just to stop the stupid actions and to save time and also the supplements. Robots are very good at repetitive work or repetitive tasks. However, if there are many different tasks, like making specialist glassware for some scientific work, then it is often better to still using human operators. Now, the advantages and disadvantages of using robots. You can find 6 advantages and 5 disadvantages. Read them, and you have also to remember them for the exam time. Now your homework is exercise 6K. Which of these are advantages and disadvantages for the employees and which are for the employers? Like this question we used to have in the exam papers for the external. So this is an important task or assignment. Please, you have to do it. 6K at page 106. You have to separate and to categorize advantages and disadvantages for employers and for employees after you are working on them. And this is the end. See you next time.
This video introduces the demonstration of skillful manipulation using a high-speed robotic system. The hand module has 3 fingers, a developed small harmonic drive gear, and a high-power mini actuator are used for each finger link. The hand can close the joints at 180 degrees in 1/10 of a second. The vision system consists of 128 by 128 photodetectors and an all-pixel parallel processing array. Using the vision chip enables various image features to be computed within 1 millisecond. This tactile sensor is a sheet-like object with only 4 wires. This sensor can measure the center position of a two-dimensional distributed load and the total load within 1 millisecond. High-speed control improves not just the speed of existing robot manipulations. Pursuing the upper limit in terms of speed for mechanical systems, we developed appropriate new control methods for high-speed manipulation. This is dribbling. High-speed active control enables the maintaining of a periodically stable motion. We call it dynamic holding. The dribbling period is around 100 milliseconds. This is pen spinning. The task is achieved due to the stability of objects experiencing high-speed rotation. The contact force and the timing of shifts about the axis of rotation are modified in real time by tactile feedback. This is throwing. The release method is designed so that the error of the ball direction is reduced by the apparent force, which is generated by a high-speed arm swing. In this way, we developed new robust control methods by introducing remarkable features peculiar to high-speed motion. Based on such a control strategy, skillful handling of more practical objects is also achieved. This is knotting of a rope. The hand can dexterously control a flexible object through high-speed sensory feedback control, regardless of its unpredictable motion. This is grasping a rice grain with tweezers. The tiny object is manipulated using a typical human tool. High-speed visual servoing enables the modification of force between finger and the tool. This is dynamic regrasping of a cell phone. This regrasping consists of throwing and catching, which contrasts with traditional methods that maintain contact state. These videos show that high-speed sensor-motor fusion has great potential to produce new control strategy and new robotic skills.